Hi, my name is Nelson Stauffer. I'm a computational ecologist with the ARS Jornada Experimental Range, and I'm going to give you a whirlwind tour of a general workflow for developing sample designs for monitoring. So what is a sample design? When we say that, we often mean basically a collection of rules and decisions that you've made that describe why in the world you're collecting data in the first place, how you're going to go about collecting those data, and then the where and when of collecting those data. And so this workflow goes through those things in order, breaking them down even further into sort of subunits to tackle in an attempt to make it sort of manageable to develop a sample design for a monitoring project. So why collect data? That's the first thing that you have to answer. So at the very highest level, you have these questions and goals, and these are often inherited from your predecessor or coming from some kind of policy that say things like, and the example throughout this will be sage grouse, that there must be suitable sage grouse habitat in high priority areas. And then you have to start asking questions like, well, where are the high priority areas? What does suitable even mean? That's where we move into objectives. And objectives are bridging the gap. They're making these more specific rather than this very general. It's highly specific, defining like what is suitable sage grouse habitat, 15 to 25% covered from sagebrush, apparently. And making that quantitative also so that you can actually relate it to quantitative data that you're gathering. Once you've defined objectives, you also need to be thinking about your reporting units. Where are you going to be summarizing the data? Where do these questions need to be answered? And in this case, we know it's high priority areas. So we can say, well, we'll report on our different high priority areas, summarize the data within them once we have the data. And a lot of this is coming from things like the Sage Grouse Habitat Assessment Framework, or you might be using the AIM terrestrial benchmark tool for this. There are a number of tools. I'm mostly going to skip them for time, though. So then we move on to how are we collecting our data? Well, we set our objectives that include things like landscape metrics or indicators, which means that we need to be picking out methods that will help us actually get those indicators measured. So we might go to a reference like the Monitoring Manual for Grassland, Shrubland, and Savanna Ecosystems and find that for cover data, line point intercept is common, standardized, and it's well documented. So we can go ahead and pull that, say that will be one of the things that we will do at each of our survey locations. And then we start talking about where and when to collect data. So the hardest part is figuring out your sample frame, and your sample frame is the full extent of all of the area and all of the time that you might place a plot to go collect data within. So if we need data on priority habitat, that means that our sample frame probably covers all of the priority habitat. We want to be able to put a sampling location anywhere within there. But the actual placement of those sampling locations is also complicated. There are two sort of major decision points. There's one major decision point with two options here. The first is targeted or non-random, where you pick key areas that are representative or you believe are representative of the landscape, which is pretty efficient oftentimes, but has the downside of not being able to be statistically analyzed because it does not fit the assumptions of the statistical tests. Or you can do random probabilistic sampling where you use an algorithm to place the points at random on the landscape, in which case you can actually use statistical analyses on the data, which is often a huge advantage. When you are doing things randomly, you can still have some control by doing things like subsetting the landscape, stratifying it, picking out and deciding how you're going to allocate the amount of effort between those. So our priority habitat areas might be how we stratify so that we make sure that some effort gets applied to each of those areas. We know that we will have data for each of them in order to answer our questions about each of them. And then finally, once we've made all of those decisions, we have to bring them together to think about, well, what's the variability on my methodology that I'm using? What's the variability of the landscape? How confident do I need to be in my answers, especially if we're doing statistical analyses? And all of that comes to how much funding do I have? What's my staffing situation? All of that comes together to decide how many sampling locations you're going to place and how many times you're going to revisit them, if at all. So just to sum all of that up, What is a sample design? It's describing why data are collected. So that's your questions and goals, the objectives that are the specific takes on those, and your reporting units. Decides how they're collected. So what methods will you be using at each plot to collect data in order to answer those questions? And then it determines where and when the data are collected with your sample frame, how you're putting points out on the landscape, and how many you're going to be putting out. And it's important to have all of this documented and known because that determines how you can responsibly use your data. For example, if it's targeted, you wouldn't be running a statistical analysis and reporting with error bars, but you could do something like plot counting and describe the ratio of plots that fit one category versus another. If you want to know more about this and about tools that apply to each of these steps, you'll have to read the article. And thank you.